Alright guys, welcome back from your extended break. I hope everyone's staying safe and healthy. While we're doing this online format for the next few weeks, 2 weeks at least, maybe more, I'll be posting videos for a lot of our lessons. Some of them I'll make myself, others I'll just find videos that are over the appropriate topic and post them for you to watch. Please make sure you're doing your part in this by watching the videos carefully, pausing when appropriate to try some examples yourself, because when you try those examples yourself, that's when you're really kind of learning the material instead of just watching someone else do it. And take advantage of the fact that it's on video. You can rewind and watch again however many times you need to. If something goes too fast, then take advantage of that opportunity. The white screen that you see is essentially like our whiteboard. I can write on it as I talk, and this is kind of how I'll do my lessons whenever I record for you guys. Alright, so the first thing I want to do is just kind of review some derivatives. Okay, so you should have looked at already by now that derivative sheet that I posted on my courses. Hopefully you're able to work through that and fill in most of it. If there's anything on that sheet that you don't have memorized yet, then again, I can't emphasize enough the importance of having those things memorized. Okay, so that's something you need to be working on if you haven't done it already. But I'm just going to quickly run through a few derivative examples just to kind of warm up. And okay, so what I want you guys to do on this page is take a second on your own to pause the video and try these derivatives by yourself. If you need to, you can look back in your notes. This first function that we're taking the derivative of doesn't take any really special rules. It's just kind of basic derivatives. The second one, though, you'll need to be careful because it's a product of two functions. And so when you have a product of two functions and you're doing the derivative of that product, you'll need the product rule. Okay, so just a quick reminder, if I need to do the derivative of f times g, I'll do f prime and leave g alone, plus, then I'll leave f alone and do g prime. Alright, so pause the video here and try these two derivatives on your own, and then play the video and see if you were able to get it right. Alright, so just to fill in the answers real quick for you, the derivative of 4 times 3 to the x is 4 times 3 to the x times natural log 3, plus the derivative of 5 natural log x. We could write that as 5 times, the derivative of natural log is 1 over x, but then I can clean this up. Usually we don't write it like this. We usually write it as just 5 over x. So I have 4 times 3 to the x natural log 3 plus 5 over x. Okay. On the second one, with some quick scratch work, we have f prime would be secant squared, and g prime is 1 over the square root of 1 minus x squared. And then applying our product rule, we just put all the pieces where they belong. So I have f prime, that's secant squared x, times g times arc sine of x, plus f, that's the tangent function, times g prime, that's 1 over the square root 1 minus x squared. Okay, so again, we just put all the pieces where they go. I've got f prime times g plus f times g prime. Okay, moving on to one more example to finish out this kind of warm-up session. Alright, so this last example with our little derivative warm-up that we're doing involves the derivative of a fraction on top I have the sine function, 3 times sine x. On the bottom I have 5 times x to the fourth. Alright, so again, just a quick reminder, if I need to do the derivative of f over g, where f and g are functions, the quotient rule says the derivative of this fraction is going to be, let's see, low d high, that's g times f prime, minus high d low, that's f times g prime, over low squared. Okay, so in this particular case, we've got f on top is 3 sine x, so f prime is 3 cosine x. G is the function on bottom, 5x to the fourth, so in this case g prime would be 20x cubed. Okay, so with all that being said, again, pause the video here and fill in the derivative. What's the derivative of 3 sine x over 5x to the fourth according to our quotient rule? Alright, to check your work, I have g times f prime, so that's 5x to the fourth, times f prime, that's 3 cosine x, minus f times g prime, so that's 3 sine x, times g prime, that's 20x cubed, and this whole thing is divided by g squared. I'm going to write this function g, this 5x to the fourth, in parentheses, and then say that I'm squaring the whole thing. The parentheses here are important. If you didn't have those, then your answer is incorrect. The parentheses show that you're squaring the entire denominator, 5x to the fourth, the whole thing is being squared. Alright, so here this does require a little bit of simplification. Just leaving the top alone for now. Maybe one thing I'll do right now with the top is I'll move this 20x cubed to the front of this second term. I have 3 times 20x cubed times sine x. The only reason I do that is it just kind of cleans things up. You have a consistent order where you have something times x raised to a power, and then something times x raised to a power. Followed by your trig functions. On bottom, here's where I'll make my first change to how things look. This 5x to the fourth squared, that's the same thing as 25x to the eighth. When you have a power raised to another power, you multiply those powers. So 4 times 2 gives you an exponent 8. Alright, to clean this up a little bit more, I want to look at all these pieces, and I notice every piece has something that's divisible by 5. Alright, so I can reduce those. That 5 reduces down to 1, the 20 reduces down to 4, and the 25 reduces down to 5. Okay. We also have 3's showing up in 2 of the pieces, the 2 pieces on top, but there's nothing on bottom that's divisible by 3, so we can't do anything to reduce those. Alright, so what I'm left with, I still have that 3, and I still have that x to the fourth. So I'll write this as 3x to the fourth cosine x minus, here I can go ahead and multiply the 3 and the 4. 3 times 4 is 12. I have x cubed sine x. And then this whole thing is divided by 5x to the eighth. Okay. The other thing I can reduce here is if you look at all 3 pieces have an x raised to some power. So I want to take what's in common there and reduce. The most I can pull out of all 3 of these would be an x cubed. So if I reduce all of these by an x cubed, I'm left with 3x to the first power for this first term minus 12 The x cubed I'm completely removing from this one, so I'm just left with 12 sine x. And then if I factor out an x cubed from the bottom, I'm left with x to the 5th. Alright, so when I reduce these x's, I'm left with I have a 3x cosine x minus 12 sine x, or 5x to the 5th. Notice here, this x and this x to the 5th, I cannot reduce those because I no longer have any x terms in this other piece in the numerator. This 12 sine x, there's nothing for me to reduce there. I can only reduce x's whenever there's something showing up in all three pieces. I've got two pieces on top separated by a minus sign, and then I've got a piece on bottom. When we reduce, we only reduce things that are common to all three of those pieces. Alright, so this is our final answer in reduced form.